Hello everyone, welcome back to this lecture. I hope all are well. In previous last two lecture, I discussed and explained about why do we need to pre-process the dataset and do the feature engineering. I discussed and what are the factor like missing values, inconsistent data, noisy data and having an outlier that make the data poor. The data we get in a raw form that have a bad properties like missing value, inconsistent data, noisy data and having an outlier, that if you feed without pre-processing of dataset and feature engineering, the it make a machine learning model very poor. It will perform very poor. So that's why we need to pre-process the dataset and do the feature engineering to get a higher performance of a model. Let's recap a few points. Let's see first. So feature engineering and data preprocessing are the underestimated steps in a machine learning. Most of the machine learning practitioners focus on the optimizing the model through hyperparameter and changing the algorithm, but they don't focus on the data preprocessing and feature engineering, which is a crucial as well as backbone of the machine learning model. That's why I am devoting a lot of time to explain this concept. When I started to learn the feature engineering and data preprocessing, so I feel very interesting this while reading, because that make your model perform better with no if you pre-process the data set and do feature engineering if required. So as we know, if you want a machine learning model very good, performing well and having a higher accuracy, higher performance, so you need a high quality data. But as you get data from the employer or from any source, the data you get in a raw form that having a incomplete, that is incomplete, inconsistent, having a noise, having a missing values and outliers. So so we need to tackle this problems or drawbacks of the raw data to make the dataset in a format that machine learning accept that, and they try to learn the pattern that are present in the dataset to having a higher performance of a model. That's why we are devoting a lot of time to understand the data pre-processing and feature engineering. Data quality is a prime factor. It will determine your success in a machine learning journey. And data pre-processing, cleaning, transforming, organizing and structuring that structure format are required. Handling a missing values, having outliers, missing values I discussed in previous lecture. If you have not seen, please watch it. And normalizing data outlier, this method I will discuss in this lecture. Handling a categorical data I will discuss in upcoming lecture. And feature engineering, creating a new feature or modifying a existing one to improve the ML model performance. And there are several techniques in feature extraction like principal component analysis, which is unsupervised machine learning algorithm that rely on the features, not the labels. They try to extracting and keeping the feature that are relevant to the dataset and removing and dimensions or features and enhance the computational resources. Feature transformation, feature generation, creating a new feature using a existing one, selecting the most relevant feature. These are important terms and concept that I'm trying to making your foundation in a machine learning very strong, and improving the model accuracy and performance. It will help you to reduce the overfitting and removing the irrelevant features, and it will help you to reducing the training time. When comes to training of model, you need to reach to the global minima So how you will reach the globe minima very early? It requires you should have a high quality data, and it will also save your computational resources and hardware also. And in previous lecture I discussed what is raw data and what is missing values. Data points are not recorded. There are a lot of reason missing data value are present in data set, like data entry error, technical failure. And I explain through example. Outlier outlier are the extreme value in the data set that significantly differ from the real. And uh, so how to handle this outlier I will discuss in this lecture. And noisy data having errors, special characters that does not signify any importance in the data set, and inconsistent data having a different format of data set, because we collect data set from the multiple resources and sources. And how to handle the missing data, we understand there are two primary approach we used in machine learning, like deletion method, which removing the missing data. If you have a none value at any n value, it will remove the rows and column as well. But we need to, while removing the rows and columns, we should ensure ourselves you will lose the information that are important, that may be important your model prediction. And imputation method, instead of removing we are trying to filling the values with some method and techniques. Mean, median, mode I discussed, and k nearest neighbor and regression imputation. So let's discuss this lecture. In this lecture we are trying to explaining how to handle the outlier. If your data set if you have a data set, you're trying to removing or handling the outlier, and along with I will explain how to transform the data set. It will help you to machine learning model will converge very fast. So first method is a outlier is a value in a data set that is uh, deviate far more than the rest of the values. I will explain through example. First understand, if you have a, let's take a pen. Yeah, suppose if you have a monthly income, if you have one feature monthly income, I'm having a salary 10k, 20k, and 25k, and one of you have a 1000k. As you see the data set, you will see this may be normal, and normal, but this is very high, that is deviate too much. So we need to handle this value, or this value is called as an outlier because it deviate too much from the rest of the values. So this is a considered outlier. If you don't handle this outlier, it will affect your model performance, because it will set aside your mean for a monthly income feature. So how to handle the outlier? So first method is Z score method, that is standard score method. In Z score method, how far a data point is from the mean in terms of standard deviation. We are taking the standard deviation, we are trying to measuring through the standard deviation. We see each data point how it is far from the mean. We will calculate the Z score for each data point. If there is a here written there is a 3 and minus 3. If Z score for data point come after 3, greater than 3 or less than minus 3, it means it is an outlier. If Z score fall in this range, so you will say your value is good, it is not an outlier. If it is going beyond this range, it means your data point is a outlier. So you need to handle it. First we are trying to detecting and recognizing the data point which one is outlier, then we will handle it, then we'll address this. So let's take example. you have a data set having a one of the feature is, and there is a corresponding values. I am taking a sub feature of a data set. This is a data set, and one of the feature. First, you have to know this is Z score. This is Z score. Here each data point here come, and the mean of the data of a feature. These are features. Uh, you can think like a I have a multiple features, so I choose one feature for simplicity and explaining the concept of Z score. And this is a standard deviation of a feature. So first I calculate the mean, taking the all of the values and divided by the how many time a number of item, and I calculate the standard deviation. How to calculate it? I have to write -1. So here I have each data point and subtract it from the mean and take the square. I will do for same for each data point and divide by n-1 number of samples I have, and take a square root. Then I will calculate the 157 approximately and 1144 mean. Okay, then I will calculate the Z score for each data point. So I will put this data point here, and this mean and standard deviation fixed for the for a feature. Then I change the each data point, then I calculate the Z score. So if this is the condition, if data point lie in this range, if a score Z score, if Z score in this range, so that is not an outlier. The given data point is not an outlier. Like for example, Z score for this point is -0.41. It means it lie in this range, so it is not an outlier. So this is not an outlier. Similarly, this is not outlier. This is not outlier. But you will see here 5.64, that is greater than 3. It means it is an outlier. The Z score if fall beyond this range means less than -3 and greater than 3. It means it is an outlier. So this data point is a outlier. So we need to choose a appropriate method to handle this outlier. If you don't handle it, it will impact your model performance. So I think you understand how to find out the Z score for each data point. First we have to take it is a formula. We take each data point and take the mean and take the standard deviation, and we change the data point, and mean and standard deviation will be fixed for each feature, and I calculate the Z score. Then I check the Z score with the range -3, and if it is outside the range, it means it is an outlier. This is the steps I follow to find out and to detect the outlier present or not. So if outlier is present, so how to handle it? So one of the ways to remove the outlier. Removing the outlier. If there error, removing the outlier. If there error, to remove this outlier. Like sometimes I take example when I start the lecture. Example is I have taken a monthly income of this 100,000 K. It may be possible. So we don't need to remove this outlier. If you think it may possible, if it not possible, so we have to remove this row or this training example. Okay, you can remove only when you think it is not required for our data set. If you think the value may be more higher, if data set allow it, so you can keep it. One second way is you have to choose one threshold. If value goes beyond that threshold, so you have to take a one value and put it. So what we are doing, suppose here we fix like a 100 is the threshold. If Z score is outside this range, it means it's outlier, so we will change this 1000 with the 100. Okay, so this is the clipping or capping the extreme value to a threshold. And second method is a interquartile range method. In this method, we are trying to identify the outlier based on the quartiles. So how to find out it? First, we will try to find out the first quartile of a data set, of a feature data set, and third quartile. First quartile, nothing but 25th percentile. Percentile, you can think like we are trying to comparing the one data set with the other data set, but in percentage we are not comparing. We are taking out, like if you get 80 percentage, it means you have 80 marks out of 100. But in case of 80 percentile, it means you are performing better than the 80% of students. You are comparing with the other students. Percentile allow to compare with the other student, but in percentage we cannot compare with other students. So that is the concept and key difference between the percentile and percentage. 25th percentile we have to find out, and 75th percentile. So we will calculate the IQR Q3 minus Q1. Then after that, and we will calculate the range. If this fall within the range, any value within the range, it means it is not outlier. If it is beyond this range, it means it is an outlier. Okay. So here Q1 the 1.5 IQR. IQR is the difference between the Q3 minus Q1. Same as 1.5 and Q3. Let's take example. So we have a data set. This data set. First we need to arrange this data set into a ascending order. After that, we will find out the Q1 and Q3. How to find out it? For Q1, you have to find out, first you need to arrange the data set in the ascending order and try to find out the median value. Like in this data set, we have 7 training examples. So this one is a median. So that is Q2, 50th percentile. Then below this range, below this value, it is a first half or lower half. Lower half. We will calculate the median of this data set 10, 12, 14. So that is the 12. So this is the Q1. To find out the Q3, the value greater than the Q2 or median, that is the second half or upper half. We will calculate the median is 19, so it is a Q3. Then we will calculate the IQR, taking a difference and calculating the lower bound as well as upper bound. Then how to handle it? So removing the value. So you will see here, here is a lower bound is 1.5, here 1.5 and 29.5. So value lie within the range, it is not an outlier. Value lies outside this range, it means it is an outlier. You will see here 10 lies, 12 lies, 14 lies, 15 also lies, 18 lies, 19 lies, 200 is not lies. So that is a outlier. That is a outlier that need to be handled. So let's move. So remove the value. If you think that is the outlier, so you can remove this value. Otherwise, you have to transforming the value. So transformation method I will discuss in later part of the lecture. And till now I discussed two methods. First is interquartile method and second is a Z-score method. And one more method is Winsorization. In this, instead of removing the outliers, we are trying to capping the values to certain percentile. Suppose replacing the top 5% highest value with the next highest non-outlier values. For example, we have a data set 10, 12, this data set. We know this is the outlier. We are thinking how to deal with the outlier. To deal with the outlier, we are not interested to removing this training example. We want this training example should be remain in this data set. So we will replace with the 19. So we will use the some strategy like replacing a top 5% highest value with the next highest non-outlier value. If you remove the 5% high value, whatever value remains, the highest among them will replace with the outlier value. And so let's discuss data transformation. We are applying the number of methods to transforming the data so that our training become a faster and speeder, and our convergence, we say reaching to the global minima, become a faster through data transformation. Scaling and transforming the data is a better way and to handle the outlier than removing them. We cannot always remove the training example or outlier because we know in reality we have very less data. We require lot of data to train the model. If you remove the less data, it means you are losing the information. So that's why we cannot compromising to removing the outliers. We can handle it the outliers. So to handle the outlier, we are trying to using the transformation method. So first is a log transformation. A log transformation reducing the impact of larger value. Outlier means the larger value, the rest of the value. Reducing the impact of the large value by taking the logarithm of the data. Let's see the example. We have a data 1, 10, 100, 1000 and 10,000. So what we will do, if we identify the outlier, you can see there lot of variation are there each data point. So we cannot use the previous method and we cannot remove the data set. So what we do, we are trying to transforming the data by using the log transformation. You can take a natural logarithm that have a base e, or you can take a logarithm that base have a 10. So I am taking a base 10 here. So if you take a log of 1 0, log of 10 is 1, 100 2. It means we are trying to converting log 100 means we are at 2. So 2 came here, and this is a property you have studied. So you will calculate log 10 is 1. So 2 is to 1 means 2. Okay. Similarly for 1000 and 10,000. So you will see transform data become more near. That data is very far. There is a lot of variation between the data points, but here the variation between data point is equal, almost equal. So it helps in reducing the extreme difference between the values. You can see here is a 9 difference, here is a 90 difference. So you can think there is a lot of variation are there, but here is a 1. It means when you transforming the data using the logarithm, so the difference between data point become a almost equal. So so log transformation help you to minimizing the difference between the values or data points. Second is the this is the under the data transformation. First is the logarithm based transformation. Second is the standardization. Means we are trying to find out the Z score here, same as I calculate in in starting of the lecture. So we're rescaling the data set to have a mean 0. We are trying to fixing the feature value or data set mean 0 and standard deviation is 1. So we take this formula, each data point we have a features, we are trying to find out the mean and their standard deviation. From each data point we are trying to calculate a z score. So that value is a transformed value for a feature. So it helps in normalize different scale of data for machine learning. What we do, we have a data set in a different scales, on a different scales. In this journey I am taking a only one feature, but in reality there are a lot of features are there. So I am taking, if we have a multiple features, so we have a each feature have a own scale. Scale means the value start and end. So we are trying to converting the values of all feature within the range having a mean 0 and standard deviation 1. It help in optimizing the algorithm very fast. So let's see the example. So we have a data set 10, 20, 30, 100, and we are trying to first I find out the mean. This is a standard deviation, this is the same formula, and then I take each data point and calculating it and finding these values. When you calculate the mean and standard deviation, you will find 0 and 1. Okay, so how you are transforming the original data into standardized data. So this is the mean and this is the standard deviation SD. Here is your data point. You will put each data point here and transform your data point that having a mean 0 and standard deviation 1. And other method is a min max scaling. They are trying to scaling the value that range from the between 0 to 1. So we will take each data point and first we will calculate the what is the minimum value in a features and their max value, and calculate the scaled value that range from the 0 to 1. Help when value have a different units like height in centimeter, weight in kg. We are trying to scale the value from 0 to 1. So in this lecture I discussed how to detecting the outliers, and after detecting the outliers and how to handle them, and what are the data transformation like min max scaling, standardization, and this transformation technique will help you to deal with the outliers having a in a data set and log transformed data set. Okay, so these three methods play a crucial role in speeding up the machine learning optimization, where what happen, we are trying to updating the values. Updation depend on the data quality we have. If you transforming the data set having a features that have a mean 0 and standard deviation 1, so your training will become very fast. You reach a global minima where loss is equal to close to 0. It will perform the performance of the model become a very high if you follow these steps, if you implement this step. So I hope you understand this lecture. If you have any concept and any method you unable to understand it, so please leave them in a comment section. I'm happy to resolve them, and thank you so much. See you in next lecture.